We are going to start laminar flow through pipe. So are you ready? Are you ready? Bolo re baba, bolo re baba. Excellent, excellent, excellent. Chalo, chalo, chalo. Let us have the quick revision of yesterday's class. I mean day before yesterday's class, the last class which I have taken on laminar flow. Let us have the quick revision. My friends, first we discussed the Reynolds experiment, then we have discussed the Reynolds number, and then in the last class I have discussed what? Fully developed flow. I have discussed fully developed flow. But a quick revision करेंगे as usual. Fully developed flow, fully developed flow. अब बेटा ये fully developed flow क्या होता है? I have given you earlier. What is this fully developed flow? आपको याद है? Do you remember, my friends? Do you remember? आपको याद है? What is the meaning of fully? आ जाओ रे बाबा, आ जाओ रे बाबा. Do you remember the meaning of fully developed flow, बेटा? Do you remember? Do you remember? Fully developed flow में क्या होता था बेटा? U was zero. U was zero और नॉन जीरो. U was non नमूने लोग. U was non zero रे बाबा. I was assuming the flow is taking place in positive x direction. If the flow is taking place in positive x direction, U is non-zero. What is zero then? What is zero then? Then the velocity is in radial direction. V is zero, W is zero. Yes, 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 yes. And I hope you are able to recollect this beautiful observation also. Dou U by dou x. Dou U by dou x was zero, whereas dou U by dou y. Dou U by dou y was non-zero, dou U by dou y was non-zero, and 100% without any doubt I can say dou U by dou z was also non-zero. Are you clear till here? यहां तक आपको याद आया बेटा? Are you clear till here? यहां तक आपको चीजें याद आई? Clear? I hope you are clear till here बेटा. इसके अलावा और क्या सीखा था हमने? इसके अलावा और क्या सीखा था? You remember I have told you in fully developed region, that means where I am having the fully developed flow, what I told you, अगर आपको याद होगा ढंग से बेटा, मैंने बताया था आपको. I have told you my friends, I have told you my friend, dou p by dou x, dou p by dou x will be negative. That means pressure will be decreasing in x direction and it will be a constant, negative constant we are going to have, negative constant we are going to have. And I hope you are able to recollect this beautiful observation. I hope you are able to recollect this beautiful observation which I told you earlier. For study, what a beautiful concept I have discussed in last class. For study बेटा ये डिस्कस किया था ना. For study and fully developed flow. For study and fully developed flow क्या होने वाला है बेटा? What will happen for study and fully developed flow? What will happen? What will happen? Anyone in the class? Anyone in the class? क्या होने वाला है बेटा? 100% without any doubt I can say AX will be zero. ये हमने प्रूव भी किया था बेटा. ये हमने प्रूव भी किया था AX will be zero. Do you remember this? चलो अब यहीं से आगे बढ़ते हैं बेटा. Let us. We had the quick revision of last class. We had the quick revision of last class. Shall we move forward? बोलो रे बाबा, बोलो रे बाबा. Shall we move forward? आगे बढ़ेंगे, आगे बढ़ेंगे. Excellent, 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 excellent. बोलिए, चलें आगे. Shall we move forward? Shall we move forward बेटा? Excellent, excellent. Yes. Good evening, good evening, good evening, ओमवीर. No problem. आ जाओ रे बाबा, आ जाओ रे बाबा, आ जाओ रे बाबा. Excellent, excellent. चलिए आगे चलते हैं. Yes, 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 yes. Let us move forward. Let us move forward. Laminar flow through circular pipe. अब बेटा ध्यान से सुन लेना, बेटा ध्यान से सुन लेना. Laminar flow through circular pipe. Whenever I am having such kind of flow, it is known as Hagen-Poiseuille flow. It is known as what? Hagen-Poiseuille flow. Of course, for deriving the relations, I am having few more assumptions. I am assuming the flow is steady flow, the flow is fully developed flow. तो याद रख लेना बेटा, Hagen-Poiseuille flow क्या होता है? Whenever we are having the laminar flow through circular pipe and whenever we are having such assumption that the flow is steady flow and fully developed flow, we will be having the Hagen-Poiseuille flow. इस चीज को थोड़ा सा याद रख लेना. चलो बेटा, now derivation पर चलते हैं. Derivation पे चलते हैं. My aim is देखो मेरा आज का एम क्या है, I want to see how the shear stress will be varying when I'm having Hagen-Poiseuille flow. Second thing which I want to see is how the velocity will be varying if I'm having Hagen-Poiseuille flow. I hope everyone is clear. What is today's agenda, beta? What is today's agenda? Today we are going to see what will be the shear stress distribution, how the shear will be varying from center line to the wall, how the velocity will be varying from center line to the wall. चलो बेटा ध्यान से सुनना बेटा. Excellent students, look at here. Wow. Let us suppose I am having a pipeline. मान लीजिए बेटा ये पाइपलाइन है. ओके फाइन. नाउ मैं कुछ एक्सिस मान रहा हूं, थोड़ा ध्यान से देख लेना, या पहले चलो पाइपलाइन के डायमेंशंस आपको बता देते हैं. लेट अस सपोज दिस इज सेंटर लाइन. बेटा let us suppose this is center line. Fine, let us suppose this is center line. This is center line. Perfect. Let me try to draw it in a proper way. Fine. आ जाओ रे बाबा. Excellent. Come fast. Today we are going to discuss shear stress distribution and velocity distribution. Beta, you know, if I want, I can derive the same equations. Whatever I'm going to derive right now, we can derive with the help of Navier-Stokes equation also. लेकिन Navier-Stokes equation से बताने की बजाय मैं आपको कुछ और तरीके से बताऊंगा. Now look at here, my friends. I'm defining few axes. Please observe carefully. Let me say this axis, beta. This axis is x-axis. Let me say this is y-axis. Let me say this is z-axis. Please observe carefully, my friend. Beautiful derivations we are going to do today. आज बिल्कुल बेहतरीन derivations करेंगे बेटा. This is x direction. This is y direction. This is z direction. We will see in a beautiful way. We will be seeing in a beautiful way. अब ध्यान से देखना बेटा. Let us suppose for the analysis purpose, I'm assuming a small fluid element, a small cylindrical fluid element which is passing through this pipe. Okay, तो देखो analysis के लिए मैंने एक fluid element ले लिया बेटा. Please observe. Let us suppose for the analysis I have taken a fluid element which is something like this. Fine. Now look at here. Let me assume this fluid element, this cylindrical fluid element is having radius small r. Let us suppose this cylindrical fluid element is having radius small r. And let me say this length of the cylinder is dx. This length of the cylinder is dx. Anyone in the class, any intelligent student of the class can tell me what will be the cross section area of this cylinder. Whatever the element I have taken, what will be the cross-sectional area of this cylindrical fluid element which I have taken? Anyone in the class? 100% it will be equal to what? Pi r square. 100% it will be equal to what? Pi r square. Can I say, my friends? 100% it will be equal to pi r square. Yes, Omkar, I know beta. Yellow is not visible. That's why I am representing the axis with that. Yes, beta. I know yellow is not that much visible. That's why I represented axis with that. Yes, excellent शिव गुप्ता, वेरी गुड बेटा. नाउ लिसन केयरफुली. अगर मैं आपको पूछूं, ये तो क्रॉस सेक्शन हो रही है, एरिया हो गया. अगर कर्व्ड सरफेस एरिया पूछूं बेटा, अगर आपको कर्व्ड सरफेस एरिया पूछूं, व्हाट विल बी द कर्व्ड सरफेस एरिया? व्हाट विल बी द कर्व्ड सरफेस एरिया ऑफ दिस सिलेंड्रिकल फ्लूइड एलिमेंट? एनीवन इन द क्लास बेटा? एनीवन इन द क्लास? 2 pi r dx बेटा. 2 pi r dx. I hope everyone is clear till here. यहां तक आप लोग क्लियर? एक्सीलेंट ओमकार, वेरी गुड बेटा, वेरी गुड. नाउ लिसन केयरफुली. बिल्कुल ध्यान से देख लेना बेटा. Now listen carefully. Try to understand what is our aim. Our aim is to find the shear stress distribution. So somewhere we'll be taking the shear stress. अब ध्यान से देखेंगे बेटा. Let me say I'm taking the radial direction also, and let me say radial direction I'm taking from the center line. This is the center line beta. Let me say I'm taking radial direction from the center line, and let me say the radius, let me say the radius of this cylinder is capital R. Let me say the radius of the cylinder is capital R. अब ध्यान से सुनना बेटा. What are the forces? आपको क्या लगता है क्या क्या forces ये जो fluid element मैंने लिया इस पर लग रहे होंगे? Look at here my friends, I have taken one cylindrical fluid element ना. Look at here, I have taken one cylindrical fluid element. I have taken one cylindrical fluid element. Any intelligent student of the class can tell me what will be the forces acting on this cylindrical fluid element. बोलो रे बाबा, बोलो रे बाबा, बोलो रे बाबा. What will be the forces acting on this cylindrical fluid element? What will be the forces acting on this cylindrical fluid element? Anyone in the class can tell me? Yes. First, whatever is coming in my mind is the pressure force. 100%. 100%. Look at here, my friends. Here I will be having some fluid element which will be applying the pressure force in this direction. Which will be applying the pressure force in this direction. 100%. Which will be applying the pressure force in this direction. What will be the magnitude of that pressure force? Of course, pressure into area. So let me say the pressure is P. Of course, cross section area is pi r square. Cross section area is pi r square. I hope everyone is clear till here. अब बेटा सुनो ध्यान से. Let us suppose the pressure is varying in x direction. Let me say the variation of the pressure in x direction is dou p by dou x. Let us suppose pressure is varying in x direction and the variation of the pressure in x direction is dou p by dou x. So look at here my friends. Let me say the pressure variation is dou p by dou x. Let me say the pressure variation is beta dou p by dou x. So what will be the pressure at this end? Beta, what will be the pressure at this end? When I am traveling the distance of dx, 100% pressure will become what? P plus dou p by dou x into dx. अब देखो बेटा यहाँ पे please don't have this bad concept in your mind that the pressure is increasing. No, you cannot say pressure is increasing because it will depend on dou p by dou x. If dou p by dou x is negative, then pressure will decrease now. Then the pressure will decrease. So look at here my friends. Please observe the beautiful concept for my beautiful students. So look at here 100%. If you observe here 100%, if you observe here at this end, the pressure force will be P plus dou p by dou x dx into area beta. Area is pi r square. Chalo, this I am able to understand. Acha beta, can I say there will be one more force which will be acting on this fluid element? क्या आपको समझ में आ रहा है कौन सा फोर्स लग रहा होगा? अरे there will be some shear force also ना, there will be some viscous force also ना. So where the shear force will be acting बेटा? आपको ये चीज समझ में आ रही है? Where the viscous force will be acting? कैसे लग रहा होगा viscous force? आप देखो बेटा. Please observe how the viscous force will be acting. Please observe. Let us suppose this is the fluid element ना बेटा. देखो, this is the fluid element. This is the fluid element. Here at one end बेटा. Please observe. Here at one end. ध्यान से देखना ये है fluid element, and if you match with your screen, here at this cross section I am having P into pi r square. At this cross section I am having P plus dou p by dou x into dx pi r square. Now the viscous force will be acting on this curved surface. The shear force will be acting on this curved surface. How much will be the magnitude of shear force acting on this curved surface beta? Shear stress acting on this curved surface multiply by this curved surface area. What is the value of curved surface area beta? 2 pi r dx. So I hope everyone is clear with this my friends. 100%. अच्छा, what will be the direction? देखो बेटा, direction में गलती मत करना. Don't commit the mistake over here. Please don't commit the mistake here. Let me say the flow is taking place from left end to right end. Let us suppose the flow is taking place from left end to right end. Can you tell me what will be the direction of shear force? Bolo re baba. Yes, excellent. Very good. Very good. Anyone in the class can tell me what will be the direction of shear force? Bolo re baba. Bolo re baba. What will be the direction of shear force? Boliye, boliye, boliye. Excellent. Excellent. Beautiful. Yes. Yes. You are absolutely correct, beta. It will be acting right to left, and of course the magnitude will be tau into 2 pi r dx. Now listen carefully. अब बिल्कुल ध्यान से सुन लेना बेटा. Now listen carefully. Can I say net force in x direction will be equal to pressure force in x direction? Look at here beta. This is the pressure force in x direction. P into pi r square. Since it is acting in positive x direction, I am taking positive. Now look at here beta. This is the pressure force in negative x direction, so I am taking negative. Minus P plus, beta ध्यान से देखना, P plus dou P by dou x. P plus dou P by dou x into dx. This is the pressure on the right face, right? Multiply by area, multiply by cross sectional area, pi r square. Minus shear stress. Shear stress is also acting in negative x direction. So tau into how much, my friends? 2 pi r dx. अब ध्यान से देखना बेटा. What will be the net force in x direction? अरे very easy रे बाबा. Net force in x direction will be what? Mass into acceleration in x. Oh my god. Oh my god. What is the acceleration in x direction? What is the acceleration in x direction? For study and fully developed flow, what is the acceleration in x direction? Bolo re baba, bolo re baba. Excellent, excellent, excellent. For study, what a beautiful concept. This I have given you in last class beta. For study and fully developed flow. For what? Oh, yes, very good, my friend. Very good. For study and fully developed flow, 100%, the acceleration in x direction will be how much? Acceleration in x direction will be 0. So this term will become 0 beta. This term will become 0. If this term will become 0, so can I write 0 is equal to? अच्छा यहाँ कुछ cancellation हुआ बेटा? Is there any cancellation? Bolo re baba, bolo re baba, bolo re baba. Are we having any cancellation? Are we having any cancellation? Yes, P pi r square is getting cancelled. Beautiful. So what I'm getting is minus, correct? I'm getting minus what beta? Minus dou P by dou x. Dou P by dou x dx, correct? This is one thing which I'm getting into pi r square. What I'm getting here? Minus tau 2 pi r dx. अब देखो बेटा, ध्यान से देखना बेटा. Can I write in this way? Tau into what? 2 pi r dx. Tau into 2 pi r dx is equal to what? Minus dou P by dou x into dx into what beta? Pi r square. Into what beta? Pi r square. Now something is getting cancelled. Something is getting cancelled for my beautiful students. Something pi is getting cancelled. Dx is getting cancelled. Yes. What else? R is getting cancelled, my friends. Then what I'm getting? Bolo re baba. What are we getting now? We are getting tau is equal to minus dou P by dou x into what beta? R by 2, small r by 2. This is the formula of shear stress. This is the expression of shear stress I'm getting. Now one beautiful question to my beautiful students. Can you tell me beta? Can you tell me how the shear stress is varying with the radial distance? Anyone in the class? Yes, Rajesh ji, correct. Now can you tell me how the shear stress is varying with the radial distance? Bolo re baba, type in chat box. Type in chat box how the shear stress is varying with the radial distance. Any intelligent student of the class, any intelligent student of the class can tell me how the shear stress is varying with the radial distance. Bolo re baba, bolo re baba. Excellent, excellent. Shear stress is varying linearly. Shear stress is varying linearly with the radial distance. Shear stress is varying linearly with the radial distance. I hope everyone is clear. I hope everyone is clear. अब मैं आपसे एक क्वेश्चन पूछूंगा, थोड़ा ध्यान से देखना बेटा. मैं देखता हूं कितने लोग इस चीज को समझ पाते हैं. I want to see one thing. Let me see how many of you will be able to understand. बेटा I'm interested in two things. और चलो नेक्स्ट पेज पे लिखता हूं. I'm interested in two things बेटा. I'm interested at center line. I'm interested at center line. अब मुझे एक चीज बताना बेटा, सेंटर लाइन पे स्मॉल आर कितना होगा? See here carefully, my friend. See here carefully, and can you tell me at center line? At center line, यहां पर बेटा, यहां पर सेंटर लाइन पर स्मॉल आर कितना होगा? What will be small r at center line? बोलो रे बाबा, बोलो रे बाबा. Type in chat box. R, वाह 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 वाह. Excellent, beautiful students. At center line, small r will be 0. Anyone in the class? At wall, what will be small r? Small r will be equal to capital R. That means, listen carefully, that means radial distance is minimum at the center line and it will be maximum at the wall. It will be maximum at the wall. So look at here, my friend. Excellent, beautiful students. Beautiful students. So can you tell me, now listen carefully, can you tell me at center line, if small r is 0, what will be shear stress beta? At center line, if small r is 0, what will be shear stress? Tau is equal to minus dou p by dou x. Small r is 0. Small r is 0 by 2. So can I say tau is equal to how much? 0. So at center line, shear stress will be 0. याद रख लेना, whenever I am having Hagen-Poiseuille flow, 100% at center line, shear stress will be 0. चलो, let us see at wall बेटा. Let us see at wall. Let us see at wall. What will be the shear stress? जरा देखते हैं बेटा, wall पर shear stress कितना होगा? Any intelligent student of the class? Any intelligent student of the class can tell me at wall what will be small r beta? Small r will be equal to capital R. So tau is equal to what? Tau is equal to minus dou p by dou x. Small r क्या हो जाएगा बेटा? Capital R by 2. So tau is this. Now, can I say one thing? This is the minimum value of shear stress. This is the minimum value of shear stress. 100%. So minimum shear stress is 0. Minimum shear stress is 0 and it is occurring at the center line. And can I say this is the maximum? This is the maximum value of shear stress, which is equal to minus dou p by dou x, capital R by 2. And can you tell me where it's occurring? कहां पर हो रहा है बेटा ये मैक्सिमम shear stress? It is occurring at the wall. अच्छा मुझे एक चीज बताओ, आपको ऐसा डाउट नहीं हो रहा shear stress की वैल्यू नेगेटिव आ रही है? How many of you are feeling shear stress is coming negative? How many of you are feeling shear stress is coming negative? Thank you so much प्रेम बेटा, thank you so much. How many of you are feeling shear stress is coming negative बेटा? कितने लोगों को ऐसा लग रहा है कि shear stress नेगेटिव आ रहा है? How many of you are feeling? हाँ, how many of you are feeling shear stress is coming negative? Thank you so much बेटा प्रेम. No. अरे shear stress is not coming negative रे बाबा. लास्ट क्लास में क्या बताया था आपको? इन लास्ट क्लास व्हाट आई टोल्ड यू रे बाबा, dou p by dou x is what? Dou p by dou x क्या है रे बाबा? प्रेशर ग्रेडियंट. एंड दिस प्रेशर ग्रेडियंट इज व्हाट? लास्ट क्लास में तो आपको बताया था, प्रेशर इन फुल्ली डेवलप्ड रीजन फॉर फुल्ली डेवलप्ड फ्लो दिस dou p by dou x is what? नेगेटिव कांस्टेंट. तो वो नेगेटिव नहीं आ रहा है बेटा, नेगेटिव नहीं आ रहा है. नेगेटिव क्या हो जाएगा? नेगेटिव क्या हो जाएगा? नेगेटिव पॉजिटिव हो जाएगा. नेगेटिव विल बी पॉजिटिव. आर यू क्लियर? Excellent. Very good. Yes. For fully developed flow, 100% due to the viscous losses, the pressure will keep on decreasing along the flow. Pressure will be keep on decreasing along with the flow, and 100% dou p by dou x will be negative. अब ध्यान से सुनना बेटा, एक और चीज आपको बताता हूं, देखो यही फार्मूला जो है ना, एक और चीज आपको यहीं पे ही बता देता हूं बेटा, देखो यहीं पे बता देता हूं, सेम फार्मूला इफ यू वांट यू कैन राइट इन दिस वे आल्सो बेटा। if I am assuming this thing, let us suppose if I am assuming this thing, pressure is changing only in x direction, अगर प्रेशर केवल x डायरेक्शन में चेंज हो रहा है, if the pressure is changing only in x direction, let us suppose we are assuming, if I am taking the assumption pressure is changing only in x direction, then what will happen beta, then dou p by dou x, the partial differentiation and total differentiation will become equal, dou p by dou x और dp by dx दोनों बिल्कुल exactly same हो जाएंगे। that is the reason why, that is the I'm taking the assumption beta, generally this is the case, generally this is the case, generally this is the case, pressure will be changing in x direction only, this is the case, and if this is the case, dou p by dou x and dp by dx are same, that's why in some books आपको ऐसा फार्मूला दिखेगा बेटा, in few books you will be finding the formula like this, minus dp by dx small r by 2. So basically they are assuming the pressure is changing only in x direction. I hope you are clear what I am trying to tell you. So अगर कहीं पर आपको dp by dx दिख रहा है तो वो भी सही है, that is also correct because there the assumption is pressure is decreasing only in x direction, the pressure is changing only in x direction. I hope everyone is clear. तो आपको अगर कहीं कहीं पर इसकी जगह ऐसा भी दिख सकता है बेटा, sometimes you can find in this way also, यही फार्मूला अगर आप कहीं पर देखेंगे, कहीं कहीं पर आपको टाउ इज इक्वल टू माइनस डीपी बाई डी एक्स कैपिटल आर बाई 2 भी दिख सकता है। आई होप एवरीवन इज क्लियर, आई होप एवरीवन इज क्लियर। चलिए चलिए, नाउ 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 लिसन केयरफुली, चलिए चलिए नाउ लिसन केयरफुली, थोड़ा सा आगे बढ़ते हैं बेटा। लेट अस सी द कंक्लूजन्स, लेट अस सी द कंक्लूजन, जो भी हमने सीखा है अभी तक थोड़ा सा कंक्लूजन देख लेते हैं बेटा, थोड़ा सा कंक्लूजन देख लेते हैं। फॉर स्टडी कॉमा फुल्ली डेवलप्ड, फॉर स्टडी कॉमा फुल्ली डेवलप्ड कॉमा लैमिनार फ्लो, शियर स्ट्रेस वेरीज लीनियरली विद द रेडियल डिस्टेंस। बेटा जो भी इंपॉर्टेंट पॉइंट्स है मैंने ऑलरेडी रेड कलर से हाईलाइट कर दिया है। सेकेंड पॉइंट इज व्हाट, minimum shear stress occurs at the center line. Of course you know minimum shear stress will be occurring at the center line having magnitude 0, and the maximum shear stress occurs at the wall having magnitude, what will be the magnitude of maximum shear stress beta, tau maximum will be equal to what, I can write, चलो d के फॉर्म में लिख देता हूं, dp by dx, dp by dx capital R by 2. Any intelligent student of the class, what is capital R here बेटा, यहां पर ये capital R क्या है बेटा, what is capital R here, what is capital R here beta, what is capital R here beta, what is capital R here, बोलिए। Excellent, yes 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 beta, very good very good very good, excellent excellent, yes yes, radius of the pipe, radius of the pipe, चलो very good beta, very good. Now few of you were messaging me about the batches also, तो मैं आपको एक हल्की सी इंफॉर्मेशन दे देता बेटा, 2 minutes please observe, look at here. Some of the students were asking me about target, gate and ESE batch which we have started from today. तो मैं बता देता हूं बेटा, target, gate and ESE batch only 2 minutes I will take, please observe. Target, gate and ESE batch जो बेटा ये जो है, first of all it is for 2021. Now so many students were asking me, sir how are we going to cover the syllabus? So look at here beta, first we will be covering up to gate, we will be covering the syllabus of gate 2021. गेट एग्जाम तक आपका गेट 2021 का सिलेबस कंप्लीट हो जाएगा। वंस यू हैव गिवन द गेट एग्जाम, देन व्हाट आर वी गोइंग टू डू इज वी विल बी कवरिंग द जीएस एंड ईए। इसके लिए आप बिल्कुल चिंता मत करना बेटा, मैं आपको पर्सनल एडवाइस दे रहा हूं। this GS and EA you should learn, general studies and engineering aptitude you should learn with the experts, from the experts। तो इसको आप Unacademy के experts पर छोड़ देना, and then whatever the extra syllabus is there, whatever the extra technical syllabus is there, that will be getting covered। तो आपको बिल्कुल चिंता नहीं करनी है बेटा. दोज हु आर इंटरेस्टेड फॉर प्रिपेयरिंग फॉर इंजीनियरिंग सर्विसेज एग्जामिनेशन इन फ्यूचर एंड दोज हु आर ऑलरेडी प्रिपेयरिंग फॉर गेट एग्जाम, इफ यू हैवंट जॉइन अनअकैडमी प्लस, अगर आपने अभी तक ज्वाइन नहीं किया है, यू कैन ज्वाइन अनअकैडमी प्लस यूजिंग द रेफरल कोड नेगी 10. दिस इज द न्यू बैच वी स्टार्टेड फ्रॉम टुडे. दिस इज द न्यू बैच विच वी स्टार्टेड फ्रॉम टुडे. ओके, तो मैंने आपको थोड़ा बता दिया. डोंट वरी अबाउट द सिलेबस, एवरीथिंग विल बी कवर्ड. Everything will be covered. You need not to worry. So many students were asking me, sir, if we are joining now, what will happen to GS and EA? Beta, GS and EA will be covered after your GATE exam only. चलिए, shall we go for the next topic? Are you ready? Are you ready? बोलो रे बाबा, बोलो रे बाबा. Are you ready? Shall we go for the next heading? Are you ready? अगर आप ready है तो चलिए फिर next heading discuss करेंगे. If you are ready, then we will discuss the next heading. Excellent. Excellent. चलिए. Now I want you people to understand one thing. Beta, can I say there is some relation between, देखो बेटा, ये जो y डायरेक्शन है और ये जो रेडियल डायरेक्शन, अच्छा चलो मैं आपको बनाकर दिखाता हूं तो आपको ज्यादा समझ में आएगा. Let me make it for you people so that you can understand in a proper way. बना रहा हूं बेटा, कोई प्रॉब्लम नहीं है. let me make it for you people so that you can understand in a proper way. देखना बेटा ध्यान से, प्लीज ऑब्जर्व केयरफुली. we will in this heading, हमारा एम क्या है बेटा? if we are having the Hagen-Poiseuille flow, let us suppose we are having the Hagen-Poiseuille flow, then we will try to see how the velocity is varying with the radial distance. So beta, look at here, this is your center line beta, this is your center line, this is your center line beta, this is your center line, fine, this is your center line, perfectly all right. आपने एक fluid element माना था, let us suppose this is the fluid element, let us suppose this is the fluid element, let us suppose this is the fluid element which we assumed, this is the fluid element which we assume. अब बेटा ध्यान से देखना. Excellent, beautiful students. बेटा फोकस करना, फोकस करके रखना. बहुत इंपॉर्टेंट डेरिवेशन है बेटा, यहां से क्वेश्चन आते हैं गेट एग्जाम में. There will be so many questions from here. तो फोकस लूज मत करना. Please keep focusing. Now look at here बेटा. Let me say, ध्यान से देखना बेटा. Let me say this is your y direction which I am taking from the wall, and of course let me say this is your radial direction which I am taking from the center line. Now let me say this fluid element, whatever I have taken for observation, it is having radial distance r, small r, है ना. let us suppose the distance from the wall, इसको यहां लिख लो चाहे तो नीचे, चाहे तो यहां लिख लो. let me say the radius of this fluid element is small r, and let me say the distance of this circumference, distance of this fluid element from the wall is, let me say this is y, इसको y मान लेते हैं बेटा. अच्छा, let us suppose the radius of the pipe beta, let us suppose the radius of the pipe is capital R. आपको कुछ ऐसा समझ में आ रहा है? Are you able to understand? Is there any relation between small r, small y and capital R? मुझे सिर्फ इतना बता दीजिए. Just tell me this thing. Is there any relation between small r, small y and capital R? बोलो रे बाबा, is there any relation? Yes, excellent Utkarsh, excellent Varun, very good beta, very good Akhil, excellent beta, Prakash very good, Prachi very good beta, very good, Arjun excellent, Shiv Gupta very good, Palak very good. Yes, you people are absolutely correct my friends, 100% स्मॉल आर प्लस स्मॉल वाई इज इक्वल टू कैपिटल आर। अगर मैं लिखना चाहूं तो ऐसा भी लिख सकता हूं y इज इक्वल टू कैपिटल आर माइनस स्मॉल आर। और इफ आई डिफरेंशिएट, देखो बेटा कैपिटल आर इज कांस्टेंट, ये चेंज नहीं होगा, ये तो रेडियस ऑफ पाइप है, दिस इज कांस्टेंट, दिस इज कांस्टेंट। एंड लेट अस सपोज आई एम डूइंग द डेरिवेटिव ऑफ both sides, then I will be getting dy is equal to d of radius of the pipe minus d of radial distance. So what I am getting is dy is equal to minus dr. अब बेटा एक चीज ध्यान से सुन लेना, आपको मैंने पहले भी एक फार्मूला बताया था, you must be able to recollect a formula which I have given you earlier. Tau is equal to mu du by dy. आपको याद आ रहा होगा, this is the formula which I have given you, tau is equal to mu du by dy. I don't want to play with the y coordinate, मेरा y coordinate में इंटरेस्ट नहीं है बेटा. I want to see how the velocity is changing. I want to see how the velocity is changing with the radial distance. That's why already I have calculated the value of dy. तो मैं एक काम करूंगा, what I'm going to do is I will be writing tau is equal to mu du by, let us substitute the value of dy which is minus dr. Excellent. So tau is equal to what? Minus mu du by dr. That's it my friends, that's it. I came to know this relation, मुझे एक relation मिल गया, I got this relation. Please observe carefully. Let me say this is equation number A. मान लीजिए ये जो है ये equation number A है बेटा. This is the formula of shear stress which I am getting from the basic knowledge. Tau is equal to mu du by dy, and dy is equal to what? Minus dr. So when I am substituting there, what I am getting is that tau is equal to minus mu du by dr. अब ध्यान से सुनना, अरे अभी थोड़ी देर पहले रे बाबा, just 5-10 minutes before, don't you think we have derived the formula of tau also? हमने already tau का formula derive किया हुआ ना रे बाबा. So let us see what is that formula. Let us see what is that formula. Tau is equal to what? क्या लिखा था हमने बेटा? Tau is equal to minus, I am writing dp by dx. That means I am assuming pressure is varying only in x direction. dp by dx r by 2. ये पीछे वाला फार्मूला भी बता रहा है कि shear stress का वेरिएशन कैसे हो रहा है, ये वाला फार्मूला ही बता रहा है. So I can do one thing from equation 1 and equation 2. Please observe carefully my friends. Please observe carefully. From equation 1, from equation A, basically from equation A and equation B. So what are we getting? Please observe carefully. I am getting minus mu du by dr, minus mu du by dr is equal to minus dp by dx r by 2. So if I want, I can write in this format also beta. du by dr is equal to minus 1 upon 2 mu minus dp by dx r. Acha, can I write in this way beta? du is equal to what? Minus 1 upon 2 mu minus dp by dx r dr. अच्छा एक काम करते हैं, let us integrate both sides. On integrating both sides. Fine. If I am integrating both sides, what will happen beta? Let us observe carefully. बिल्कुल ध्यान से देखेंगे. This will become u. Look at here. Du will become what? Du will become u na. Beta du will become u na. So u is equal to what I am getting? Minus 1 upon 2 mu. अच्छा ये आपको समझ में आ गया? आपको ये समझ में आ गया ना? चलो एक स्टेप लिख देता हूं बेटा. Don't be confused. Integration du is equal to integration minus 1 upon 2 mu minus dp by dx बेटा, minus dp by dx r dr. अब ध्यान से देखना बेटा. Can I say u is equal to, अरे this is constant, this complete is constant. देखो जो constant है ये सब लिख रहा हूं ध्यान से. कल ही तो आपको बताया था this is constant बेटा. dp by dx is constant, negative constant, so this total term is constant, this total term is constant, so it will come out of the integration beta. If it is coming out of the integration, minus 1 upon 2 mu minus dp by dx, integration of r will be what? R square by 2. So what are we getting? We are getting u is equal to what beta? Minus 1 upon 4 mu minus dp by dx r square. अब देखो बेटा, I haven't kept any limit, मैंने कुछ भी लिमिट नहीं रखी है, तो ऑफ कोर्स आपको समझ में आ रहा होगा there will be a constant of integration, there will be a constant of integration because I am not substituting any limit, so 100% there will be a constant of integration. Now listen carefully, बिल्कुल ध्यान से सुनेंगे बेटा. How to find this constant of integration? ये constant of integration कैसे निकाल सकते हैं बेटा? How to find the constant of integration? How to find the constant of integration? Anyone in the class? कैसे निकालेंगे बेटा? देखो, can I say at wall? आपको ये चीज समझ में आ रही है? At wall, here, at wall, what will be the value of u? देखो, when r is equal to, at wall r is equal to capital R ना, small u कितना होगा बेटा? Small u will be 0. आपको समझ में आ रहा है? Why? In my first chapter I have told you this concept of no slip condition I will be discussing in laminar flow through pipes. आपको समझ में आ रहा है ये क्यों होगा? बोलिए, पहले चैप्टर में मैंने बताया था एक कॉन्सेप्ट. I have told you one concept and I told you I will be using this concept in laminar flow through pipes. क्या नाम था उस कॉन्सेप्ट का? Yes, excellent. You are absolutely correct. According to no slip condition. Very good beta. According to no slip condition at r is equal to capital R, u will be 0. Substitute कर दो. देखो, I know at r is equal to, at small r is equal to capital R, that means at wall u is equal to 0. अगर मैं रखता हूं तो क्या आता है बेटा? देखो ध्यान से, 0 is equal to what? minus 1 upon 4 mu minus dp by dx capital R square plus c. So what is the value of c I am getting from here? C is equal to what? Minus will become plus 1 by 4 mu minus dp by dx R square. So this is the value of c. Let me substitute this c in equation number c. ये जो c की वैल्यू है, इसको मान लीजिए मेरे पास एक इक्वेशन c है. Let us suppose I am having some equation c. Substitute this value of capital C constant in equation c. तो ध्यान से देख लेना बेटा. Substituting capital C in equation c. So what are we getting? We are getting u is equal to what beta? minus 1 upon 4 mu. देखो बेटा ध्यान से, minus dp by dx small r square plus 1 upon 4 mu minus dp by dx capital R square. अगर मैं इसको ध्यान से लिखना चाहूं बेटा, ऐसा लिख सकता हूं क्या? u is equal to what? 1 upon 4 mu minus dp by dx into what? Capital R square minus small r square. This is the final expression, my friends, which is representing how the x direction velocity is changing with the radial direction. So आपको समझ में आया how the u is changing with radial direction? Anyone in the class, any intelligent student of the class can tell me how the u is changing, with the small r, how the u is changing with the small r. बोलो रे बाबा. Come on everyone, बोलिए कैसे चेंज हो रही है? According to this formula, I'm not talking about 3D, अब 2D में ही बताइए कैसे चेंज हो रही है? Parabolically. Is it correct, my friends? Is it correct? बोलो रे बाबा, टाइप इन चैट बॉक्स, टाइप इन चैट बॉक्स। बोलिए। Yes, yes, he was saying yes. Yes, excellent. Yes, yes, excellent. Now I started getting your responses. Yes. अब मैक्सिमम वगैरह देख लेते हैं बेटा, मैक्सिमम वगैरह देख लेते हैं। आपको तो पता ही है कैसे देखना है, तो एक बार देख लेते हैं कहां पर मैक्सिमम होगी वेलोसिटी। लेट अस सी वेयर द वेलोसिटी विल बी मैक्सिमम। लेट अस सी वेयर द वेलोसिटी विल बी मैक्सिमम। देखो ध्यान से बेटा, कैन आई से एट सेंटर लाइन? Anyone in the class? At center line what will be small r? Bolo re baba, type in chat box, type in chat box. At center line what will be small r? Small r will be 0. If small r is 0, what will be u? U will be 1 upon 4 mu minus dp by dx capital R square minus 0 square. So can I say u is equal to what? 1 upon 4 mu, 1 upon 4 mu minus dp by dx capital R square. Yes. So at the center line this is the value of velocity in x direction. At wall ये तो पता ही है, ये तो हमारी बाउंड्री कंडीशन ही थी ना रे बाबा। At wall of course you know when small r is equal to capital R, इसमें मुझे बताने की जरूरत नहीं, यही तो हमारी बाउंड्री कंडीशन है। When small r is equal to capital R, you know u is 0. So I hope you are able to understand the maximum value of velocity is occurring at maximum velocity of the velocity in x direction. Maximum value of the velocity in x direction is occurring where? At center line. This is maximum beta. This is the maximum velocity. This is the maximum velocity and this is the minimum velocity. This is the minimum velocity. अब ध्यान से देखना बेटा, मैं आपको एक और चीज बताना चाह रहा हूं, प्लीज ऑब्जर्व केयरफुली बेटा। जनरल फार्मूला विच आई हैव गिवन यू इज दिस, u is equal to 1 upon 4 mu। देखना ध्यान से बेटा, दिस इज द फार्मूला विच आई हैव गिवन यू, u is equal to what? 1 upon 4 mu minus dou p और dp by dx लिख लो, minus dp by dx capital R square minus small r square. This is the formula to find the velocity at any radial distance. देखना बेटा ध्यान से, u is equal to, can I write in this way, 1 upon 4 mu minus dp by dx Can I take this r square common, capital R square common? If I am taking capital R square common, what I am getting? 1 minus what? Small r square divided by capital R square. अच्छा ये क्या है बेटा? What is this? Are you able to understand what is this? बोलो रे बाबा, type in chat box what is this? अरे this is your u max ना, this is your center line velocity na, this is your maximum velocity na. So what I am getting, there is a relation. The velocity at any radial distance small r is equal to what? U max into 1 minus small r square divided by capital R square. So this is the relation between u and u max beta. अगर आपको u और u max के बीच में relation देखना है, then this is the relation beta, where u is the velocity at any radial distance, u max is the maximum velocity which is occurring at the center line, and small r is the radial distance where I am having the velocity small u. Is it clear to everyone? नहीं बेटा, एवरेज वेलोसिटी नहीं बताई बेटा अभी, I haven't discussed about average velocity बेटा, अभी एवरेज वेलोसिटी नहीं बताई बेटा मैंने, I haven't told anywhere average velocity. ध्यान से देखना बेटा, this is not the average velocity. Please don't be confused बेटा, don't be confused. This is not the average velocity. This is the velocity at radial distance small r. This is the velocity, this is the actual velocity of the fluid particle at radial distance small r. This is not the average velocity. The concept of average velocity I will be telling you tomorrow. The concept of average velocity I will be telling you tomorrow. This is the maximum velocity of the fluid particle which is at the center line. चलिए आपको ये चीज समझ में आ गई। चलो थोड़ा सा कंक्लूजन देख लेते हैं बेटा, what we learned from here. तो देखो ध्यान से, for study fully developed laminar flow, देखिए ध्यान से, for study comma fully developed laminar flow through pipe, velocity varies parabolically. Velocity varies parabolically with radial distance. Second point, minimum velocity occurs at the wall. जो minimum velocity होती है, it occurs at the wall having magnitude 0. Maximum velocity occurs at the center line. Of course, maximum velocity कहाँ पर occur होती है? Center line पे. Given by the expression what? U max is equal to what? 1 upon 4 mu, 1 upon 4 mu minus dp by dx, minus dp by dx कैपिटल आर स्क्वायर. आई होप एवरीवन इज क्लियर. चलो आपको अब एक डायग्राम बनाकर, बेहतरीन सा डायग्राम बनाकर आपको दिखाता हूं कैसे कैसे चीजें वेरी हो रही है, तो आपको मजा आएगा बेटा. लेट अस सी द फाइनल कंक्लूजन. Let us see the final conclusion. My beautiful friends, please observe the final conclusion. Please observe the final conclusion. Just for my students, I will be drawing this diagram. So please observe carefully. Please observe carefully. My friends, let us suppose I am taking this cross section to show the shear stress variation. Let me say this cross section I am taking for showing you the velocity variation. Okay. Let me say this is the center line. My friends, let us suppose this is the center line beta. Let us suppose this is the center line from where I am taking the radial distance. From where I am taking the radial distance. बिल्कुल ध्यान से देखना बेटा, बिल्कुल ध्यान से देखना. Let me say this is the pipe. Let me say this is the pipe which is having the radius capital R. बिल्कुल ध्यान से देखेंगे बेटा. Let me say this is the pipe which is having the radius capital R. Now listen carefully. बिल्कुल ध्यान से देखना. Let me say the radial distance I am taking from here. यहां से हम लोग रेडियल डिस्टेंस ले रहे हैं बेटा फ्रॉम द सेंटर लाइन. दैट्स व्हाई आई एम राइटिंग लाइक दिस. अब ध्यान से देखना शियर स्ट्रेस कैसे वेरी कर रहा है. वी हैव सीन एट द सेंटर लाइन शियर स्ट्रेस इज 0. तो यहां तो 0 होगा बेटा. एट द सेंटर लाइन शियर स्ट्रेस विल बी 0. नाउ एट द वॉल शियर स्ट्रेस विल बी मैक्सिमम. तो देखना बेटा, देखना, दिस इज वॉल, दिस इज वॉल, दिस इज वॉल, हियर द शियर स्ट्रेस इज मैक्सिमम. अब ध्यान से देखना, अगर मैं थोड़ा सा रिप्रेजेंट करूं तो ये भी तो वॉल को ही रिप्रेजेंट कर रहा है ना. दिस इज आल्सो रिप्रेजेंटिंग वॉल, दिस इज आल्सो रिप्रेजेंटिंग वॉल. सो हियर आल्सो यू आर हैविंग द सेम मैग्नीट्यूड ऑफ शियर स्ट्रेस. आप चाहे तो लिख भी सकते हैं. इफ यू वांट यू कैन राइट हियर आई एम हैविंग द मैक्सिमम वैल्यू ऑफ शियर स्ट्रेस एंड दिस इज इक्वल टू माइनस dp by dx capital R by 2. Fine. Now from the center to the wall, if I am moving, the shear stress will be varying linearly. The shear stress will be varying linearly. The shear stress will be varying linearly. तो देखो बेटा इस तरीके से कुछ shear stress vary होता है. Something like this your shear stress will be varying. Something like this your shear stress will be varying. Something like this your shear stress will be varying. I hope everyone is clear. अच्छा, डायरेक्शन से कंफ्यूज मत होना बेटा. I am not representing any direction. देखो I haven't represented any direction बेटा. मैंने कोई डायरेक्शन नहीं दिखाई आपको. आई हैवंट रिप्रेजेंटेड एनी डायरेक्शन. सो उससे कंफ्यूज बिल्कुल नहीं होना है आपको. यू नीड नॉट टू कंफ्यूज विद द डायरेक्शन. ऑफ कोर्स द डायरेक्शन ऑफ द विस्कस फोर्सेस विल बी अपोजिट टू द फ्लो ओनली. ये जो लेंथ है ना, दिस लेंथ ऑफ these lines, the length of these lines are representing the magnitude. There is no relation of the direction. मैंने कोई एरो नहीं बनाया ना बेटा. So these length of the lines are representing the magnitude of the shear stresses basically. ठीक है. So you can see the minimum value is occurring at the center line. The minimum value is occurring at the center line and it is 0. चलो अब मैं आपको velocity profile बना के दिखाता हूँ. शायद आपको velocity profile में मजा आए बेटा. Please observe. At the wall, velocity is 0, which is u minimum ना बेटा. U minimum at the wall velocity is 0. U minimum 0. Now at the center line I am having the maximum velocity. At the center line I am having the maximum velocity. चलो यहाँ पर मैं एरो बना देता हूँ because the direction of the velocity is in this direction only. तो मैं चलो एरो बना देता हूँ. No problem. Here I will be representing the arrow because this is the direction only. Now this is your u max beta. This is your u max. U max is how much? U max is equal to how much? 1 upon 4 mu. 1 upon 4 mu minus dp by dx into capital R square. यही है ना. Now how the velocity is varying? अगर आप देखेंगे the minimum value is occurring at the wall, the maximum value is occurring at the center line, and the velocity is increasing parabolically from the wall to the center line. तो देखो बेटा कुछ ऐसा बनता है. अगर आप थोड़ा सा फील लेकर देखो, what a beauty, vertex will be somewhere here. What a beauty for my beautiful students. वाह 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 वाह, excellent excellent. कुछ ऐसा बनेगा बेटा. You will be getting something like this. You will be getting something like this. Yes, yes, yes. Excellent, excellent. You will be getting something like this. Very good, very good. I hope everyone is clear. I hope everyone is clear. तो अगर आप 2D में देखेंगे, if you see in 2D whatever I am representing, it is parabola. But if you see in 3D, it will be paraboloid. है ना? अभी आपको ये कैसा दिख रहा है बेटा? It is looking like parabola ना? Parabola, parabolically. But if you see in 3D, the same parabola will become paraboloid. Paraboloid बन जाएगा ना? हर तरफ से आप देखेंगे. Similarly here you see this is varying linearly. This is varying linearly. I hope everyone is clear बेटा. हर चीज आज की क्लास का अगर आपको डेरिवेशन समझ में नहीं आया, I don't care. You are not able to understand the derivation, I don't care. But I hope you are able to understand whatever I have written on this screen. यहां पर जो भी लिखा है बेटा, if you are able to understand, my job is done. If you are able to understand, my job is done. अगर आपको जितना भी लिखा है मैंने यहाँ पर, if you are able to understand, my job is done. अगर ये जो भी मैंने लिखा है, if you are able to understand, I am very happy बेटा. My 1 hour of efforts are successful if you are able to understand whatever I have written here. आज की क्लास का पूरा स्नैपशॉट यही है. आज की क्लास का पूरा स्नैपशॉट यही है. दिस इज टुडेज क्लास. दिस इज टुडेज क्लास बेटा. अरे झमाझम, व्हाट अ डायग्राम, व्हाट अ डायग्राम. अरे व्हाट अ डायग्राम. एक्सीलेंट एक्सीलेंट. आ गया, समझ में आ गया मेरे स्टूडेंट्स को. सब समझ गए सर, सब समझ गए. थैंक यू सो मच तबरेज. व्हाट अ ब्यूटी, व्हाट अ ब्यूटी. सर नाउ माई डाउट इज क्लियर. चंदन योर ईच एंड एवरी डाउट विल बी क्लियर बेटा. आप बस थोड़ा पेशेंस रखो, आप लोग थोड़ा पेशेंस रखिए. मैं बोल रहा हूं, मैं आपको गारंटी दे रहा हूं 100% आपके डाउट्स क्लियर होंगे बेटा. जो भी आपको पढ़ा रहा हूं 100. व्हाट अ डायग्राम सुशांति सिंह, व्हाट अ डायग्राम. मजा 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 मजा. एक्सीलेंट एक्सीलेंट. हैप्पी. आई होप एवरीवन इज हैप्पी. और मजा 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 मजा. साई प्रीतम डॉनकड़ा हैप्पी हैप्पी सर हैप्पी. अर्जुन क्लियर सर, क्लियर क्लियर. एक्सेलेंट माय ब्यूटीफुल स्टूडेंट, माय नेगी सोल्जर्स, माय नेगी सोल्जर्स. उत्कर्ष. ओके ओके ओके. थैंक यू सो मच अर्जुन. बेटा कॉटी फ्लो का मैंने कब बोला महेश? महेश कॉटी फ्लो, रिमेंबर यू गो टू माय लास्ट क्लासेस एंड यू सी कॉटी फ्लो के पीछे पड़ गए आप. कॉटी फ्लो मैंने 2 प्लेट्स के बीच में बताया था. ये तो पाइप है बाबा. ये लाइन देखकर आपको प्लेट क्यों लग रहा है तब से? थैंक यू सो मच ओमकार. थैंक यू सो मच. थैंक यू सो मच. ऑल क्लियर ऑल क्लियर ऑल क्लियर. वेरी गुड बेटा. किसी को कोई डाउट है तो पूछ लीजिए. महेश बेटा कॉटी फ्लो टेक्स प्लेस बिटवीन 2 प्लेट्स बेटा. हियर वी आर डिस्कसिंग. हाँ, जब डायग्राम और राइटिंग क्लियर होती है तो पढ़ने में मजा आता है बेटा. मैं आपको फ्रैंकली स्पीकिंग बोल रहा हूं. सिर्फ आप लोगों के लिए मेहनत करके मैंने बहुत ट्राई किया है कि लिखूं अच्छे से, और आप लोगों के लिए मैं ट्राई करता हूं. आई शुड राइट नीट एंड क्लीन बिकॉज आई नो so many of you people are just taking these PDF at the reference. मुझे पता है मेरे पास काफी बच्चों के मैसेज आते हैं कि सर आप जो भी PDF दे रहे हैं हम बस उसी को ही एक नोट्स बनाकर रख रहे हैं, कलेक्ट कर रहे हैं. तो आई नो दैट्स वाई. थैंक यू सो मच चंदन. थैंक यू सो मच बेटा. ब्यूटीफुल. अरे व्हाट अबाउट अदर्स रे बाबा. बाकी लोग बोलिए अगर आपको कोई डाउट है तो बेटा. यहां तक चलो.